Okay, so in terms of finding whether a multivariable function is continuous, one really nice thing you can do is you can try to visualize it. That's not always possible, but in this case, we can certainly make a graph of this function. Okay, so I've gone over here to Desmos, and if you just Google for Desmos 3D, you will get this visualization. And so you can play around with this function. It looks very strange, but you can notice that it doesn't look like a nice, smooth egg carton or like an upside down dome or bowl. It definitely looks very jagged, and it doesn't look like an insect wiggling around on some pass would actually make it in towards the same point as an insect would on the other side of the surface. So this intuitively looks like a very badly behaved function. So I'm going to conjecture that this is not continuous, and it's easier to prove that a multivariable function is not continuous because you just have to find some path where the directional derivatives are not equal. So I'm going to hop back over here. I'm going to look at two paths. Now, you're welcome to choose any ones you want, but I think these ones will work out pretty well for you. I'm going to do the first one, and then I'm going to leave the second one for you to do. So I'm going to do the limit as x goes to 0 of this expression, but I'm going to come in on the path where x equals y. So wherever I see an x or y, I can replace it with the other variables. So I'm taking the limit as x goes to 0, so I'm going to leave x's into the problem. So I've got an x squared times y, but I know y is equal to x, so I'll replace that. Down in the denominator, I'm leaving the x squared there, and instead of a 2y squared, I'll have a 2x squared. Now, I can't do the limit right now because it's 0 over 0, but I can certainly simplify and then try to take the limit. So if I do that, I get x cubed in the numerator, and the denominator get x to the 6th plus 2x squared. I'm going to divide by the highest power term, and up in the numerator, I'm going to get x. Down in the denominator, I get x to the 4th plus 2. Now, if I try to take the limit, I don't get 0 over 0. What I get is 0 over 0 plus 2, and 0 over 2 is a defined real number. 0 over 0 is bad, trouble. It's an indeterminate form. So don't tell me that, or you're going to probably get I'm never mean, but you're going to get a comment that says, watch out. But anyways, we have 0 over 2. That is totally defined. We know what's going on there. That is just 0. Now, your task for the homework is to repeat this process, but you're going to do something a little different. You're doing the limit as y equals 0, as y approaches 0. And then you're looking at the expression now, but wherever you saw an x squared, you're going to plop in or substitute in a negative y and see what happens there.